So, welcome back, everyone. So then we will continue with Kelly Shortridge. She was at Troopers last year as well with some fancy topic, I would call. And now she's back with some practical magic. So the stage is yours.
Thank you. Can everyone hear me okay? Yeah, cool. So today I'm talking about practical magic, so looking at behavior-based safety design in IoT security. Really thinking about what are the kind of hands-on things we can do rather than just talking about everything's screwed and everyone needs to fix everything. So to start, I'm Kelly Shortridge. I'm a product manager at Security Scorecard, which is a risk management platform. I mostly research the intersection of behavioral economics and information security, also looking at behavioral game theory. I do that on my nights and weekends because I'm a huge dork, probably like a lot of people in here. I just love security. So I think this is a very appropriate quote to start off anything about IoT security. I usually solve problems by letting them devour me, which is by Kafka, which if you know, Kafka S is not exactly a good thing. But InfoSec seems to have this view. So if you look here, this is Google Trends. IoT has kind of skyrocketed since the 2014 timeframe. IoT security has kind of skyrocketed in its own way, but not nearly as much as the discussion on IoT. So we're really letting the problem devour us. I think we're actually engendering a Kafka-esque paradigm for IoT security. It's overly complex. Developers don't know what to do to navigate it. We throw a ton of data at the problem, but we're not actually fixing anything. Really zooming in on IoT security, you can see kind of the rise in trends with the Dyn DDoS and the Mirai botnet obviously got most of the news. That's what spurred a lot of the discussion. There's also a spike there, which as near as I can tell is because of RSA and all of the marketing. Probably every vendor was talking about IoT security in the context of botnets. And then more recently, the Reaper botnet also caused news about this to spike. So IoT botnets are really the first and I would call most ravenous boss of the IoT security battle. We aren't seeing anything particularly advanced yet. It's mostly around like taking over devices. And what's worse is that it's all about default passwords. So for my, it was 60 default passwords led to a 100,000 node botnet attack against DIN. But we're still promoting that complexity and a seemingly endless set of hurdles for IoT developers. We're not just saying, okay, make sure that default passwords aren't there. We're saying a lot more. So lackluster IoT security, I think part of the reason why we have this track, and there are tracks at a lot of conferences, is because we all know that IoT security kind of sucks right now. But our ideas that we've been proposing for at least based on that since 2014 just aren't working. But I do think by understanding behavior, we can start guiding choice and supporting secure habits. So in this talk, I'm going to talk about what the existing suggestions are for IoT security, what are some of the incentive problems that are leading to these issues, just the basic principles of behavior-based design, and then also some ideas specifically for IoT security. So the existing suggestions. I want to start with some of the government regulation. So the FTC recommends building in security from the beginning, which is not actually simple, but it sounds really nice. But they don't give a lot of concrete guidance beyond that. Mara, who I believe, Mara Tam, who's speaking later at this conference on one of the other days, she pointed me to the fact that the FDA actually has really comprehensive guidelines, both for pre and post-market. Pre-market, you can take a look, they're about 10 pages each. It's a lot of documentation, basically documenting the risk and your threat models and what you're doing, as well as threat modeling itself. So they have grades for basically, for medical devices, is it critical? Could it cause death if it's taken over? Moderate if there's some sort of injury, and then low is just if there's not any sort of injury or harm if it's taken over. Post-market, it's mostly monitoring, making sure that there aren't bugs that are disclosed, and also having some sort of strategy to be able to deploy any mitigations you need to. OWASP also has a bunch of stuff. It's definitely a lot, particularly if you're a developer that doesn't know a lot about security. They have their IoT testing guide, IoT attack surface areas, principles of IoT security, and so on and so forth. But it's really designed for a penetration tester user persona. It's not friendly for developers. Cisco also, as you might imagine, because they make a lot of the things in network devices, they have their guidelines, which include secure analytics, which I believe the subheader to that is visibility and control, whatever that really means, network enforced policy, and then authorization and authentication. But again, there's nothing clear and straightforward for a developer that doesn't know a lot about security. There's also the concept of compensating controls. So these are things that are not made by the manufacturers themselves. They're post-market remedies by third parties. The problem is the burden is then primarily on the end user. So the enterprise or the consumer has to buy additional protection to mitigate any sort of gaps based on the controls provided by the manufacturer. So here things like actionable real-time behavioral analytics for visibility and intelligence for IoT. I would say it's about effective as healing crystals, but that's my personal opinion. And it may be feasible for enterprises, but if you think about end consumers, what are they really supposed to do? There's not really a consumer-grade SIEM out there. So what are the incentive problems that's leading to this? A primary one that you hear a lot, just if you're kind of into economic theory, is the principal agent problem. So someone else is making decisions for you or on your behalf, but you actually bear the cost of it. So classic examples are investment managers. They're choosing stocks, but ultimately you're the one who loses money. Politicians are another example. They're obviously making policy decisions, but a lot of time they're actually shielded from the consequences. The agent in this case has their own self-interest. It's likely not the same as yours, so the principal and agent self-interests are very different. This leads to moral hazard, so people take more risks if they don't have to bear the costs. I think that's something pretty intuitive. Like, if you're just given a bucket of money, you're probably gonna be more speculative with stocks unless it was your own money. I think the next level of this is, for example, Equifax. The problem with Equifax, the revenue has actually been up since the breach, and technically they're making money off the breach because the insurance payment, I think, was $110 million, but the costs so far are $30 million. The problem is their customers aren't actually the consumers. So when our data is stolen, or the Americans in the room, our data is stolen, it's not like we can stop using Equifax. We don't have a choice. So this leads to a really excessive moral hazard problem. Another thing I've talked about a lot in other talks is prospect theory. So this is the idea based on empirical evidence that people care about relative versus objective outcomes. So people maintain some sort of reference point against which they measure some sort of outcome. So classic example, I live in New York. After the financial crisis, like investment bankers, for example, went from having $1 million bonuses to no bonuses. They were still making a ton of money, but to them it felt like it was absolutely horrible. They were destitute because it's on a relative basis. Because of this, people tend to overweight small probabilities and underweight large probabilities as well. So I've talked about this a lot in the context of being worried about Stuxnet-like stuff when really you're probably going to be phished. But in the context of IoT, you're probably overhyping low probability vulnerability exploitation, where the problem really is that you still have default password set. Another issue is loss aversion. So people prefer to avoid losses versus acquiring the same gain. So again, based on empirical evidence, losses hurt about 2.25 times more than the equivalent good feels good. So framing security as a time and a cost sink, like it currently is, and like it's something you have to do even though it's painful, actually facilitates that natural resistance, because it feels like they're losing time or money when they're actually implementing security. In that vein, there's also hyperbolic discounting. So basically, future rewards are discounted versus the present. So the famous experiment is the marshmallow experiment. So you can get 10 marshmallows in an hour or one marshmallow now. The kids and adults actually mostly went for the one marshmallow now. We care about getting that immediate satisfaction. The problem is a lot of security initiatives are long-term investments, so they're not getting that immediate salient satisfaction. Another part of this is the dual system theory, which it's system one versus system two. I call it lizard brain versus philosopher brain. So the lizard brain is basically like super fast, unconscious, automatic, where the philosopher brain, it takes more time, it deliberates, it really thinks through problems. The problem is most policies that we have in place, like the FTA or the FDA or FTC's policies, work on system two. It's assuming we're already thinking through problems. We need to work with system one instead. We need to be replacing those automatic, non-conscious decisions. So rather than saying, oh, we're not going to worry about this bug for now, let's just do this, we have to make security a habit. Another problem that I've seen is overchoice. So if you've heard of analysis paralysis, if you have too many options, you're not going to know what to do. So the problem is I've read some of the recommendations, and I'm not a developer, but I've done enough that I can tell, like, literally a 10-page IoT attack surface document. If you've never been introduced to security, you're going to have no idea what's going on. You're going to have no idea where to start, so you're not going to really be able to do anything at all. You need something simplified. That's just how humans work. So overall, we have to start thinking about how people actually think, and we have to work with that. We can't work against it like we currently are. So this leads into behavior-based design. There's been a ton of research into this. A number of governments, notably, I think, Ireland, the UK, the US under the Obama administration started working on some of this as well. But behavioral economists basically got paid to come up with schemes, particularly in the context of increasing tax revenue. So for example, in the UK, they sent out forms, I'll talk about social norms in a bit, basically saying, you know, everyone else but you is paying your taxes, why haven't you paid them? Like, tell us a specific time and date that you're gonna pay your taxes. And they started doing sort of A/B testing to see how they could increase basically the number of people that were actually paying their taxes on time, with a lot of success. So the reason why these are getting funded is because generally you actually see improvements, and I'll go through some of those examples. So what is choice architecture? This is a key component of behavioral-based design. If you've read Nudge, I highly recommend you read it. But this is where choice architecture was first talked about, or at least named. So the idea with choice architecture is you design a presentation of choices, like presenting them in a specific way to promote improved decision-making. A lot of it is just how you say things, not what you say. The theory behind this is some amount of automatic processing just can't be avoided. Like, it's a fact of life, we have to deal with it. But you can also counteract biases when you're presenting the options to start triggering automatic processing in a more positive way. So a really good example by Dolan and his colleagues was the Mindspace framework, which is an acronym I'll go into for behavioral design. So basically laying out what are the things you can think about for any sort of given problem. So the first is the messenger. People dismiss information from sources they don't like and respect. I think we're all familiar with this with like the influence operations of the US. People like their info wars or whatever the equivalent is on the left. Another example is doctors tend to listen to their peers rather than governments or associations. Parents have been shown to listen to their pediatricians versus, like, you know, again, FDA rules. So who is transmitting the information is actually really important. Incentives, so you hear about this a lot in a lot of context, but one thing to keep in mind based on the prospect theory is losses can actually be more motivating than rewards. So with weight loss, for example, there's been some success, and I think a few startups around this, but having people deposit money at the beginning of the year, basically that money is tied up. They can only get that money again if they actually go to the gym a certain amount of times or meet weight loss goals. So when you're thinking about incentives, you also have to consider clawbacks and withdrawals, not just like bonuses. Norms are also really important, and sometimes people underweight the importance of these in decision making. So people tend to follow social standards even when it's counterproductive. So there's a lot of work done, particularly on college campuses, for how to reduce drinking rates or improve, like, safe sex rates. So what they do is they actually publish statistics. Let's say it's, you know, only 10% of kids binge drink on a weekend. Most college adults probably think it's closer to 50%. So what they see is rates actually go down when they start publishing the real statistics. So we're really influenced by understanding what other people do and thinking that we're conforming to normal behavior. Another thing is defaults. People prefer things to remain the same. It's just inertia. The classic example is for 401ks in the US. Because we don't have a pension system, people put aside part of their paycheck into these funds that generally invest in kind of an aggregate stock market measure. But what they've done from a behavioral design point of view is when you join the company, you were opted in automatically. And what they found is that very few people actually opted out. So once they're opted in, they aren't going to change it. But if they start opted out, very few people actually change it to opted in. Realistically, it's not like everyone is suddenly changing their mind in those two scenarios. It's just inertia. You can call it laziness, but I like to say inertia. Salience. It's basically anything novel or interesting and relevant draws attention and influences choices. I've talked about this in another context, which is basically when we see all of the APT headlines and whatever sort of attack, you'll see startups pop up to address that very niche case, and people actually buy them, or they at least get funded. And that's because that information is salient to us. We don't see, like, the quotidian phishing sort of attacks every day, so we don't think about it as much. As an example, doctors, when they were presented with cost information up front about a procedure, doctors actually ordered fewer of the tests. So when that information was salient and present, it actually informed their decision making. So basically, because people have limited cognitive resources, whatever the things like flashing right in front of us, we're going to pay more attention to. Priming, this one, it's very hard to leverage. So Disney World does this a lot, actually. Senses of consciously influence us. So I know that they play, like, certain music, but they also have, like, I think it's the what is it called, a funnel cake smell, not actually where the funnel cake stand is, to like lead you towards the funnel cake area to get you to buy more. Same with like cotton candy and other food. So there are unconscious influences. Another study they've done, it shows that bigger plates, for example, cause people to eat more. We don't even think about it, but it influences our behavior. Affect is basically emotional reactions are our brain's first responders. That's what triggers us first to perform some sort of action. Social media preys on this all the time, whether it's a super happy emotion or disgust and outrage, like it influences us to like, click, whatever. Commitments, those are judgments basically you make in advance to create sort of automatic actions. So you're ensuring there's some sort of mechanism in place so you adhere to behavior. Because again, thinking about like weight loss programs, if you make some sort of commitment device, even if it's paying a really expensive gym membership, you're more likely to adhere to it. So it's planning in advance for basically your crappy behavior later on. Then finally, ego. People like to feel better about themselves. People like thinking they're good people and having a positive self-image. So if they think they're helping make the world a better place or that they're improving themselves, they're more likely to do something. So that's Mindspace. So after Mindspace, those are kind of the main categories for behavior-based design and main things to think about. There are also things like reinforcement mechanisms, which is in the vein of incentives. So you've probably heard of both negative and positive reinforcement. The jury's still out on which is better as far as empirical evidence. Again, negative does seem to work a little better. It's also interesting that positive reinforcements sometimes can backfire, particularly if they're monetary, which I'll touch on in a bit. For example, if you are wanting a friend to help you move, if you offer to pay them, they're less likely to do it. They'd rather, again, feel like good people and feel like they're doing something because they're nice. So pay for performance actually lacks empirical evidence for fixing moral hazard. So for example, if you're an investment manager and you're paid directly dollar for how well you do, you don't actually perform better than your peers. What does seem to work is setting clear, achievable goals and then having kind of like a team-based approach or benchmarking versus other people, not just in the context of whatever you're doing. So in my opinion, fix all the bugs is neither clear nor achievable, so we're really doing the wrong thing. And the goal setting must be matched with feedback, ideally immediate. If you have feedback that's too delayed, they won't get it. So I have cats. I don't know if anyone else has cats, but if the cat gets on the counter and you spray them 5 minutes later, they won't necessarily understand why. But if you're spraying them like immediately after they get on the counter, they'll get it. We're obviously a little more sophisticated than cats, but the point still stands. Like if we fix a bug and we immediately get some sort of gamification, like we've done a great thing, we get a free lunch, that's a lot more powerful if a year from now during bonus season, we get 5K more because we fixed bugs. Framing effects are also important. So basically you want to reduce the gap between the concern about the problem and willingness to act. I think a lot of us, and it's true based on, again, on empirical data, environmental problems, we're all aware we have to save wildlife, we have to conserve more. But when we're thinking about that, because when we're reading the news, it's different than we're just like buying a bottle of water, right? Or grabbing a bottle of water. So you have to reduce that gap between when you're concerned about the problem and when you're acting on it. One way to do that is also focusing on leveraging system 1 to your advantage by altering habits. So when planned behavior is carried out repeatedly, it starts becoming more unconscious. It also needs to be in the same setting, which gets into how do you create a habit loop. I don't know if any of y'all work for social media companies, because then you're probably super familiar with this. But from what I've found, very few people in security are actually that familiar with this. So step 1 is routine. How can you actually make the behavior repeated? The key is making it stable, frictionless, and fitting into existing context. So for example, someone like Spotify, what they need as far as stability is they need a stable Wi-Fi connection. No one will keep using their service repeatedly unless that component's there. Context can be something like people tend to floss more if they do it right after brushing their teeth. They're already at the sink, they're already doing something with their teeth, it makes sense. You also want to minimize the perceived effort and also the number of decisions the user has to make. So that's why social media sites, a lot of their obsession from a UX point of view is how to actually reduce the number of clicks to get to whatever like lights up the dopamine part of the brain. Step 2 is triggers and rewards. So contextual cues are important. So basically, if X, do Y. A good example from the side of like physical safety is enter the car, buckle your seatbelt. Very straightforward things where once you have the right context, you know exactly what to do. There's also what I call like the magical brew of rewards. You want short-term and accumulated long-term rewards. So again, think about the idea of you get some sort of, even if it's not that meaningful, but you get some sort of immediate gamified like stimulation when you fix some sort of bug. But then maybe a month from now, you do get some sort of cash reward. Having that blend really reinforces the mechanism. Then step 3 is ingrain. So you want to foster ample opportunities for practice and interaction. That's part of the reason why, again, social media sites will have you like suggestions like set your status or post a photo. They'll start prompting you to go into the platform more and really reinforce that it's part of your daily routine. So it's also important that observing some sort of action isn't as powerful as interacting. So you really want to get hands-on. Like if you just watch someone floss their teeth, like it's not going to be the same as if you're physically doing it. You also want to cultivate a sense of meaning, so some sort of deeper purpose. Basically, the idea here is like people don't want to feel like creatures of habit. They want to have some sort of sense of identity. They don't want to think they're just machines. So, for example, with runners, if you want to get into a running habit, if you start to identify with a runner, you join some sort of group, you know, I'm a runner, group.com, like you buy really special running shoes, you say like, yes, I'm a runner, you're more likely to stick with it. So with that, how can we apply some of these ideas to IoT security? And I'll preface this by saying I don't think any of these are like super simple or straightforward. I'm also trying to tackle it from a what I would call micro policy point of view. Again, Maritam is like brilliant at macro level policy from the perspective of governments. That's not my arena. It's more thinking about if you were on a team, for example, managing developers, or if you work in an IoT manufacturer and you want to help kind of embed security into the culture, what are some of the things you can try? So step 1, as I said before, you want to set concrete goals. Building in security, like the FTC guidelines, is just way too nebulous. You have to think about what actually you care about in the context of your security. I also think it depends a lot on what part of IoT you're in. So again, medical devices, there's an actual risk of loss of life. You have to have a very different threat model than if it's like Amazon's Alexa. So as far as clear asks, I'm going to talk about a checklist later. And I know checklists may sound really boring and simple, but as far as empirical evidence, like humans really love checklists. It's also why BuzzFeed has all those numbers list like 8 things you'll be shocked about if you're a millennial. Like humans really love ordered lists and numbered lists. I also think there's an important conversation to be had about what value actually means in the context of IoT security. I think you can consider, again, having perfect security, like no bugs in the firmware, whatever else. That could be very high value, but I would disagree. So I think value should really consider the maximum security benefit at the minimum cost. So you have to think about what does improved security mean, again, in the context of whatever sort of IoT you're doing. So consider fewer bugs. Eliminating any low-hanging fruit to the attacker. Again, making sure that users have the ability to change default passwords. You have 2-factor authentication. You have to really think critically about what you mean by improved security. But it's also reduced costs. Like I think if you think about, this is also true just in enterprise security. If you're being a little more proactive, you won't have to spend as much on like crazy, crazy high lawyer rates and incident response rates. And it's true here, if you're proactive about it, you're going to save money over the long run. So I think you have to consider both. I would also put in here, but I think we're not there yet, is ideally it also improves user usability. Right now, on the enterprise side, they really care about privacy in the context of IoT, consumers less so. But generally speaking, it's an argument that I've had with a lot of people, but I'm very much so of the opinion that if you improve security UX, you're actually improving all UX. But I just don't think we're there yet. But I do think there's opportunity to start turning security into a habit from the perspective of developers at IoT manufacturers. So teams should have a regular, brief time and space to review security goals. I would even say, like, if it's the same room, that's even better. Again, thinking about every time I get into a car, I buckle my seatbelt. How can you start, if it's sprint planning, you have your 10-minute security digest. Even if you don't have anything super pressing that week, make sure to talk about something related to security. Just making it a habit will start ingraining that sort of notion of making it a habit. So context cues. I also think this is important when you're in the design phase, and I'll get into my checklist. But starting to have context cues for example, If we have a login portal, that's something we're building into our device, we need to require the change of default credentials during setup. Or, if we have some sort of web accessible portal, like we need to sanitize input, or we need to make sure we're not using custom API protocols. Vladimir is actually talking about this later today, so go see his talk. But I think it's really important to figure out what sort of context you can create during the design process to make sure that every time, again, like we're collecting user data, what are kind of the checklist of items you need to run through? So I think it's also important to specify attainable steps with minimal complexity. So again, looking at the OWASP list, like it's absolutely massive. Like I didn't want to read it and I did, and I really care about security. So I think you have to distill like what are the key kind of 5 things for phase that we really care about. And I chose my 5, you may have a different 5, but it's making sure that you can very clearly articulate these are our 5 basics that we have to review each time we're building something. I do think very suitably and also conveniently, security is a pretty easy, I guess, an easy thing to make have a deeper meaning, right? It's helping protect users, it's helping protect safety, it's helping protect privacy. So I think you can very easily frame it as a noble cause and make people feel like they're doing something good and that they're good people. So how can we leverage the Mindspace framework for IoT security? So finding the right messenger. I think preachy InfoSec people is probably not the right way to do it. I'm not saying I'm not a preachy InfoSec person, but most of the stuff I hear on IoT security is from basically really loud people on Twitter, and occasionally people speaking at conferences. I think, for example, like people on Hacker News, which are their own very special brand of preachy, but again, thinking about like what messenger will the IoT developers care about? Like, it's not going to be us. It's going to be whoever they're looking up to. So we really have to start working kind of across the aisle, so to speak, and reach out to the right people to help spread the message. Another idea in the vein of incentives is gift some sort of budget, like make people feel like they've been awarded something so you can then take it away, which sounds really bad. There's a lot of moral debate around some of this choice architecture, but it works empirically speaking. So basically, if they don't meet certain security goals, again, the very tangible ones that you list out, then you take that away. And they'll feel the pain of that loss, so they'll want to avoid it. I do think you can also use positive incentives. Again, I think there's a lot more to be done around gamification for security goals. But if you want to start, I think this is the easiest way. For norms, I think you also want to start treating security habits that way, like it's something normal for developers to do. I personally would have no problem kind of like tweaking the statistics, so to speak, and say like 90% of our developers fix bugs within 3 days. And basically you have not, it's been a week and you haven't fixed them. Make them feel kind of bad about it. Like maybe your developers don't actually fix it, but if that's your goal, like there's really no one being harmed in the making of that statement. So I think it's well worth at least trying it. Because you really, again, want to foster that sense of like everyone's in it together and put the pressure on people to make them feel like they're kind of the black sheep security-wise. I also think, again, thinking about the doctors who reduced the number of really expensive procedures they opted for when they saw the prices, you want to start showing the longer-term expensive of options to highlight the ROI of proactive security. So this blends the default option and salience a bit. The idea here is you probably at some point, particularly if you're one of the big manufacturers, you have the costs of whenever you had the last time, particularly for like a medical device, you had to go back and patch and refactor, re-architecture, whatever else. You probably have those man-hour costs. Map those out versus like the, let's say, extra 50 hours it takes to do it right the first time, and just put those two next to each other and then remind people like, this is the choice you're making right now. You're going to cost the money, let's say, the company 5 times as much money. Really put it out there in front of them. So I think transparency around the quality and cost is super important. So again, thinking about the easiest measures with the highest impact. It isn't just about highest impact. If you did like a sort function, that's not the way to go. You really want to be looking at what's the easiest for someone to implement. For example, like ensuring that default passwords are changed in the user workflow when someone's setting up the device is pretty straightforward versus a lot of other stuff you can do in security, and it has a huge payoff. So you have to think about it that way. I think you can also start to control the instincts, again, thinking about affect, that emotional reaction, just by slowing down and considering threat modeling. So I've dealt with this before at my organizations, even just talking to people in defensive security groups at enterprises. if you have some sort of security incident or some bug, just taking a step back and really digesting, like, what's the severity, what's the impact, what do we need to do about it, starts to move you into that system 2 thinking. So kind of making this part of your process that for everything you do a threat model will be really helpful in that vein. Another idea I have is for commitment, provide some sort of team bonus, let's say quarterly, if you complete the checklist, which I'm going to show in a minute, then you also fix bugs, let's say within 30 days. If not, that money goes to charity. Otherwise, the team gets it. Again, individual-based incentives, empirically speaking, don't really work as well as team-based incentives because that way everyone pitches in. These are some of the charities I found that are for good causes in the vein of programming and security, just some ideas. But this has also been used, I think, in the legal profession and in the enterprise safety, meaning physical safety, like on manufacturing floors. They've actually tried this whole bonus and then goes to charity. And the nice thing is it's not like you're just ripping away a bonus, at least it's going to a good cause, so regardless, they'll end up feeling like good people. I also think another idea in the vein of people have those relative views of themselves is you want to start benchmarking these companies publicly. So if you haven't seen it, there's the two-factor auth list, which I think is just twofactorauth.org, which is basically a list of consumer-focused companies that have two-factor available as an option or not. Amex, for example, is not on the list. So it's a way to kind of give credit, but also shame people who don't have two-factor enabled. I mean, Shodan, you can kind of proxy this, but having some very simple way for consumers also to see, here are all the companies that actually let you change default credentials, here are the ones that don't, would be useful. So again, as silly as it sounds, checklists really work. So the best example of this is the World Health Organization's surgical safety checklist, which I think reduced the instance of error, including death, by at least 36% and also reduced costs. I think it's $26 per operation, which doesn't sound like a lot, but hospitals still care a lot about any sort of costs. So checklists have been proven to work. And from what I found, there are no checklists other than these massive documents. So the idea here is you have very streamlined steps, a very small number of them per lifecycle stage. Design, build, and test, and it's from a team point of view. So first, you want to design the UX workflow for the user to change default passwords everywhere. So I think Vladimir is going into this in his talk, but it's not just the web portal. You have to consider your FTP servers. That's a common problem, is that the IoT manufacturer lets you change for one, but not all of them. Second, you can spoof headers to look like the most common web servers, so that way it's not as easily discoverable if someone's looking for devices, say to add to their botnet. So that's another very simple one you can do. You can encrypt data in transit with SSL or TLS. You'd be shocked at the number of people who don't do this, but it's something very basic. They should not be worrying about anything related to firmware, whatever, until they're actually doing this. Also, don't call bash scripts from the web interface. That seems, again, like an obvious thing, but again, worry about this before you worry about any of the other stuff. Then also don't use custom API protocols. I almost put don't roll your own crypto in here, but at this point that's a meme, and I try to not use meme in my presentation, so this is number 5 instead. So just use REST or SOAP. So I'm going to actually put together a much nicer checklist once I have a little more time. You can see it actually fits on one PowerPoint slide with a reasonable font size. So basically in the design phase, you just have, does it have a login portal? Yes or no? Yes, and we will allow the change of default creds. User data? Yes, and we encrypt data with SSL or TLS, and so forth. So you're actually going through and just checking yes or no. It's that straightforward. So if it's internet connected, you spoof headers to appear quote-unquote normal. Then also simple stuff kind of based off that checklist, again, from the World Health Organization. You just cross-check from the teams of what critical measures to be taken. So it's not relying on one person to make sure all of this is in place. For build, it's, again, a lot of this seems very redundant, but this is part of what ends up working. So you share essential information concerning the security steps across the whole team, so everyone's on the same page. You confirm that every member understands the requirements, that if yes, they have to do those things. You also go through, has anything new been added? Do we have to go through these steps again? And making sure, for example, if it's now interfacing with the internet, what do we need to do now? Then also enumerating the anticipated security events. So what are the critical or non-routine controls required? How long will implementation take? What are the anticipated impacts? Again, really simple, straightforward stuff, but if you're doing this every time you do a sprint planning or feature review, it's gonna get you very far ahead. Then finally, on the testing phase, so I have a section for both testers and builders, which I think that's how a lot of teams work. There's like QA and then the people actually working on it. But I would definitely be open if anyone has suggestions on that. So the tester confirms basically their account controls. So again, the basics, default credential alerts, lockouts, ideally two-factor authentication available. Also listing out the data used on the device. So this is something the FDA requires, and what the FTC recommends is you at least kind of have enumerated any user data that you're using. Ideally, you're also minimizing that data or at least anonymizing it, but at least you'll have some sort of list in this case. Then also whether there are any vulnerabilities to be addressed, like is there anything that's missing? For the builders, it's what are the key concerns about management going forward and any future security concerns. So back to the enterprise security example, when I did a somewhat unofficial survey, it was basically about how long does it take per month to maintain certain security controls. I wasn't anticipating this because the largest option I had was 35 plus hours per month, and SIEM, I think, was 75% of that bucket. So when you implement that, like, you aren't necessarily anticipating the ongoing maintenance, but you need to because that's going to be part of your time requirements going forward. Then also the instructions for immediate post-testing security management. You draw them up together along with the testers. So this is part of like the FDA recommending that you have some sort of plan for when you deploy mitigating controls. So in conclusion, this is really black magic, by the way, because you're kind of influencing people to do your will, which I personally find pretty cool. So IoT security ideas have to treat developers as time-constrained humans. Like, they're not going to be able to do everything. You have to be realistic. Prioritizing security can go against incentives, but I do think that can also be changed. Right now, security is viewed, again, as that time and kind of human cost center, but it doesn't have to be. What I think the industry's done so far is propose a very complex kind of like end game level. Again, thinking about the game boss structure, we're really focused on the final boss when we haven't really even been able to defeat the first boss. So they're too formidable. If you're a developer, you don't know what to do yet. The compensating controls, which is kind of where the market's taking off right now, at least from a funding perspective, just aren't enough. Like, we're expecting magic post-hoc, and that's never going to work. We have to start earlier before it's actually deployed. I do think practical magic using behavioral design can improve decision making. Again, it's actually looking how humans behave and how we can fit into their workflows to start encouraging kind of the automatic processing of good security practices. So the goal is straightforward ways to erode risky habits and replace those habits with good security habits. As an example, a basic one-page checklist is a simple way to start growing your security culture. If you're using it every time you're developing a feature, every time you're using sprint planning, you're going to start thinking through it every time, even if you don't have the checklist in front of you. I think as an industry, this is my personal opinion, but we're kind of wallowing in this like, IoT security is broken, like no one's listening to us, it's all terrible, nothing's gonna happen. But we're letting the problem devour us and we don't have to. Like, there are actual ways we can help fix it and not just scream into the void. And I always close with this because I think it's true for anything in security. It's good enough is good enough. Good enough always beats perfect. If you're at least like eliminating the low-hanging fruit and covering the basics, like that's good enough, or it's at least good enough for now. And if you're familiar with kintsugi, it's basically the Japanese repair broken pottery with gold leaf. I view that in the same way. You may have broken processes now, but there are ways you can implement little tricks in order to improve them and actually make them work. So with that, I will take any questions.